So now that we have our spawner working, let's look into how we can actually destroy objects that go off screen. If you noticed before when we ran our game, the objects will just continue. Once they go off screen, they're still taking up memory even though they're not being rendered. So to make this more efficient, let's go into our scripts folder. We're going to create a new script and we're going to call this destroy off screen. Then let's open this up in MonoDevelop. Let's add a few public properties to this in order to keep track of 1, when the object is off the screen, and 2, when it should actually be deleted. To get started, we'll make a public float called offset, and we'll set this to 16. This will represent the value of how far off of the screen it needs to be before it gets destroyed. Next up, we'll create a private boolean for off screen. We'll use this as a flag to know that the object actually is off screen and needs to be destroyed. Next, we're going to create a private float for the off-screen X value. We'll set it to 0 by default. And finally, we're going to need to create a private property to store the rigid body. Let's create an awake method and set the rigid body 2D value. Now, inside of our start method, we're going to need to figure out where the off-screen X value actually is. The center position of the screen is always 0, 0. So we're going to need to take half of the screen's width and use that as our value. So let's start by setting off-screen X to equal the screen width divided by the pixel perfect camera's pixels to units. This is going to give us the actual width of the screen before we cut it in half. Remember, we have to readjust for the scale of our camera to take into account how everything has been altered, either being scaled up or scaled down based on the different resolutions. From here, we can divide this value by 2, and then we'll add the offset. Meaning, even though we find the halfway position of the screen, we're still going to take a little bit extra off in order to account for how far off the object needs to be from the screen. Now let's go into the update method and add in the logic to calculate when the object is off of the screen. We'll start by creating a variable to store the position X. Next, we'll need to keep track of the actual velocity so that we know which direction the object is facing. Here, we'll go to the body 2D and get its velocity X value. Now, in order for us to calculate this, we're going to want to get the absolute value of the X position. Now, the X position could be positive or minus depending on what side of the screen it is. But for us, what we really want to calculate is the value of the X position greater than the off-screen X? So here, we'll create a condition, and we're going to use math absolute value to convert any possible negative number into a positive one. We'll wrap this around the position X. Next, we want to see if it's greater than the off-screen X. Now, if this is true, what we're going to do is test the direction to see if we're either going off the left side of the screen or the right-hand side of the screen. Here, we'll see if the direction X is less than 0 and the position X is less than negative off-screen X, we know that we're off-screen. Now, let's test for the opposite direction. If the direction X is greater than 0 and the position X is greater than the off-screen, we also know that this is off-screen. And finally, if we haven't been able to detect whether we're off-screen, we're going to set the off-screen flag to false. Now, at the very end of this update loop, we can check the value of off-screen and see what we need to do. In this case, if off-screen is true, we're going to want to call a method on out of bounds. Now, let's copy that name out because we're going to need to create the method right below it. Here, we'll create a public method with a return type of void called out of bounds. And inside of it, what we're going to do is simply call destroy on the game object. Now, later on, we're actually going to talk about how to recycle these game objects. So we're going to add in one more piece of code that'll be future facing. Before we actually call destroy, let's just simply reset the off-screen value to false. Later on, when we actually reuse this object, even though we don't physically destroy it, we're going to want to make sure that it gets reset when we remove it from the screen. Now, let's save this scene, go back into Unity, and in our prefab for obstacles, let's add Destroy Off Screen. Also, let's increase the offset. We'll make this 32 so that we have a little bit more room for our desk to go off the screen. Save the scene, and let's run it. Now, when an object goes outside of the camera's view, it should disappear. We can check where the camera's view is by simply selecting the camera from the hierarchy view, and you'll see the outline. Now, we have a very efficient way of spawning new objects and destroying them once they go off the screen. But it would be even more efficient if we could actually reuse these objects instead of completely destroying them. So coming up next, we'll talk about object pooling.